fast, right? We're going to talk about all of that. Then if it's a controller, an action, we always can make it async. So user does not experience so let's start with database. Database is like one of the key things in our apps. So basically, SQL already optimized for queries. If you set indexes right, it's pretty fast. But you need to be careful with indexes because indexes eat memory, right? There are sometimes the database requests are too long. For example, instead of saying like kitten.select where kitten ID is 5 or kitten ID is 6 or kitten ID is 7, you could use in, which Rails uses now by default. And but if you want to see like how your query is being processed, you can always use explain. Have you heard about explain? Who does not? Nice, yes. Okay, we're going to talk about explain later. Then we can measure indexes in memory to see, not only to see how much RAM you need to use for a database, but also to see like maybe you have some indexes that you forgot about that just take a lot of time in memory, or some data that you don't really need to clean up your data. Then for database, the bottleneck of Ruby is after Ruby received the result from database, it creates these models, right? And that is a slow part of Ruby. We'll talk about it. It's actually, this part is more Rails than the database, but I just included it here. The best optimization of database is just avoid using database and use cache, because cache is really fast, and we're going to talk about it. We'll benchmark some things. Cache is really fast, and it provides a really snap experience. Then you have to keep an eye on database configuration, like how many RAM do you use, how many cores, and we'll talk about it later too. And then you can use a slave. Everybody knows what slave is? Everybody knows. So that means who doesn't know? Nice. I like how everybody knows, and then who doesn't know, raise your hands. A slave is a copy of your database that is read-only, that you can use for some operations. It has some delay, like minor delay in synchronizing, but you can use some like analytics things to read from a slave database, not to block your main database. Then also a tip about database is it's also more like a Rails, not a database, but I'll just tell it now. Instead of each, use find each, so it does not load all records to the memory, because Ruby is will eat a lot of memory, and that will cause your Puma workers to restart when they go out of memory. So use find each or find in batches, or just update all, which just update all records in one query, or delete all, right? So avoiding using loops in Ruby is better. Okay, database explain. It's really simple. You just write your query in Rails, like customers where not first name is nil, and ID is 1, 2, 3, order last name, limit 1, right? Do you understand this query? So basically, it looks for people who have names and not this, and just orders them by last name, and limits to 1. And it just preloads messages and explain. And it will give you a calculation what's your query is going to look like, with some cost, which reflects how fast it is, basically. And you can see here, I just made a screenshot. Can you guys see the screenshot?
It's a little hard to see.
Well, sorry, at the end we will try doing that, and I'll increase the screen. Then database and memory performance. You can measure indexes in memory. In Postgres, for example, you can run this query. I'll share this slideshow with you so you can remember it. You run this query and it will give you all indexes, all tables with the sizes, right? And you can see like which is the heaviest, which is less heavy. So you can just kind of have idea what's going on with your database, because at some point we just didn't know. We had like a bunch of messages, like millions of messages and millions of customers, and then we didn't know that we also tracked API calls, and API calls table was the biggest table in our database, and then we just removed it completely. Also, we used to use Heroku database, but then we moved to RDS. Anyone has an experience with using RDS or Heroku database? Both? Nice. So which one do you like better? Huh?
I mean, RDS is, people don't know RDS is Amazon's solution, AWS solution for databases. And yeah, I use Postgres on RDS. It was fine, it worked, yeah. I mean, Heroku is a little more hands-off. RDS, you get a little more control.
Yeah, so in Heroku, if you want to upgrade the database, you have to have a downtime. You can just, you have to create a new database and then copy over the data to the new database. And then while you're copying the data, you kind of have downtime. But with RDS, you can dynamically update, saying like, hey, I want more memory for my database. And you can do it dynamically. So it's pretty easy. It's cheaper. It's better. And we moved from Heroku database without downtime, just scaling down the workers and still having a web dynos running. So they would create workers but won't execute them while the data was copying. It was like 25 minutes. And then you would just execute all workers that were created from Redis. So we didn't have any, we had a delay, but no data was lost. That was pretty nice. Then cache. Cache is really important. Cache is something that will make your experience really snappy and fast. Basically, Redis is 74,239 operations per single second, while a database it's like approximate data. It's 500 operations per second. So Redis is way faster, right? And if a user goes on a page and you don't use database, it's just super fast. So for example, we cache last message. And the good thing about Redis is that it can be expirable. So you can cache only the latest data, right? So for example, if you have on Facebook Messenger, right, you can cache only the latest threads, right? Because you don't care of like a guy you messaged like 5 years ago that you don't even want to think about, right? Or like your ex that you don't even, yeah. So you don't have to cache that. And it's expensive. So that's why in cache you can like give it some expiration, set some expiration time, and cache only the latest things. So they work really fast. And for all things that the chances that you go and find this message, this thread with your ex, like that you had like 5 years ago, are really low. So you don't have to cache it. But in case you want to go there, you still have the record in database. So we cache. We try to cache as much as possible. So it feels like our app is really fast. And it is really fast, actually. We also use local storage to cache. It's pretty convenient. Like, for example, a list of users, like Yoka workers, they barely change. And if it changes, we use WebSocket to sync. But we keep it on in the local storage, so it's really fast. And messages drafts, we also keep it in large local storage. So in our case, if you like open our app, yeah, from it, basically it syncs, but we keep it in local storage, so it's even faster. So recaching to increase snappiness. I have a video to show you how fast it is. See how fast it is? I switch threads, and it's like just instantly changing because everything is cached here. Everything you see is cached. So the threads on the left. Our product is similar to Facebook message from like a feeling, but multiple people can collaborate on like working with customers. Like if you had a Facebook Messenger, and you also could give access to like your friends, so everybody can respond for you. That's what our product is, if I do like a simple analogy. And I think it's even faster than Facebook. So everything is cached, and it's just instant, right? So because last messages are cached, but if you scroll up to see all their messages, it will actually show you loading icon and be slower because it will actually go to the database, to slow database with all the data and fetch all messages that probably you won't need to. Any ideas how? I know a hotkey. Well, this is good enough. So we cache last messages, threads, and just a lot of things. Okay, DevOps. What is DevOps? I would say DevOps is like just hardware. No? It's like how you connect hardware to your software needs. Do you know Edge 14? What Edge 14 is? Yeah, it's a Heroku error when you run out of memory. So basically, sometimes your Puma workers run out of memory. Puma workers are also on the web. They just call Puma workers. It's a little bit confusing. So basically, your app runs out of memory, and then it just runs out of RAM, and it starts using disk memory, which is so slow, so everything will be timed out, right? And we had a lot of that. We couldn't figure out for some time like why we would time out at some points. One of the reasons we time out is because over time, because of garbage collection, the amount of RAM that your app uses just increases, and never goes back. And so what people do is just basically restart your app. So it's like, you have an old version of Windows, and then at some point you have to just kill it and just reinstall Windows again, or Mac, because it just gets so slow for like unknown like UFO reasons. And there's a gem called Puma Worker Killer that kills your app, and it basically restarts from a clean start from like a low memory. It also does a smart job of killing different Puma workers at different timing, so your user just won't notice. Also, it's easy to just check stats of how many. Just look how much memory your app eats, and for example, in Heroku, it's very easy to see, and I actually have a screenshot of a memory usage. See 3 a.m. Do you see 3 a.m.? It's where Puma got restarted. So we restart our workers like once a day. So there are two things. Either we restarted it because we deployed, or because Puma Killer just killed this worker. I also wanted to talk about how to calculate how many web dynos you need based on your average response and RPMs, but I'm going to talk about it later. Also, maybe, not sure if you guys know, by default, if you deploy, right, your app gets restarted. So users will have some downtime, maybe like 30 seconds. And on Heroku, there is a pre-boot option that you can use. So when you deploy, it basically runs the migrations, restart the workers, but it would restart Verb later, like in maybe 1 minute or 2 minutes. So basically, there is no downtime, and they will restart Verb workers one by one, so users can feel downtime. But you have to be really careful with it because it runs the migration on the back end, but it won't restart old Verb workers for a little while. That's why we deploy, if you have like a serious migration with like a code improvement, we deploy it in this order. First, we deploy the version of code that would support 2 versions of database. Then we run the migration, and then we deploy a version of code with removed support for the old code, for the old version. That's how we do it. All right.
Michael, I have a question.
Yeah.
You have to go out of your way. Presumably, you have automated tests, and you want to run them against both versions of the code and both versions of database. You know your first version of the code works with the first version of the database. So your first change to the code, so you have to run the test against the old version of the database.
Yeah, we usually have both tests. We usually have both tests. We have if you have a new feature, we have new tests with new feature. And we'll try both tests, and both tests should pass.
Right, but they have to pass with both the old schema and the new schema. So usually Rails will complain like, "Hey, you have a pending migration or something."
Oh.
You have some old schemas, you just like have that. Is there a tool that helps you with this like 2-stage or 3-stage migration pattern?
Oh, I don't remember how we ran it. I can recall it now, but
Can you rescue the error if it's an error and like record it? But I guess the test will fail.
yeah. So the test will fail, and it's an interesting question. Also, what you can do is, sometimes you have one version of migration on one branch, another version of migrations on another branch. You can, and you switch the branches, right? It won't give you you have a pending migration sometimes, but then you have a different version database. So I guess you can fool your Rails migrations like that.
You just delete the latest migration.
Yeah, maybe. I don't remember how we did it.
I think we put more macroscopic tests that tested whether the feature fully worked, and in both cases, the feature would work because our code was set up to solve for either schema. So we didn't write microscopic.
Yeah, that's a good question. Yeah, I can recall the exact method that we used. But maybe, yeah, I'll include this to my next presentation. Thanks. So the next, let's talk about Ruby. You guys familiar with Ruby? What's bad about Ruby? What's good about Ruby? I have a couple more slides about that. But in Ruby, first of all, if you have a Ruby on Rails app and you want to scale it, you have to use the latest version of Ruby. You know why, right? Who doesn't know why? 1, 2. Okay. So you can ask everybody else because they apparently know. Compared to 1.8.7, 1.9.7, Ruby after version of 2, they have a better garbage collection, and they are faster. And Also, they're faster a lot because of the garbage collection. It got better. And there are tests. I don't have them here. Maybe I should have included it. I didn't know that many people, didn't know. But the latest Ruby runs much faster because garbage collection for Ruby is heavy. Like, let's say if Ruby uses 2 megabytes of memory, that's because it has 1 megabyte of data and the other megabyte of garbage collection. And it's actually, the more data is in memory, the more garbage collection the Ruby uses, and that's why it's heavy on CPU. And the latest Ruby is just much better with garbage collection. It's much faster. I didn't include benchmarks, but I probably will for my next version of the presentation. And so the less memory you use for Ruby, the better. Because I'll go ahead. This is how New Relic shows. We optimize everything, but it's really hard to optimize the ocean of Ruby. The ocean of Ruby. So blue thing there is Ruby, and it's like this one of the slowest parts. So basically, we try not to use too much memory with Ruby. For example, from the database, we want to load just the only things that we need. So for example, we don't want to map the whole bunch of models if you just need the IDs. So instead of map, we would use pluck. And also there is a good advice that says modify arrays and hashes in place using each exclamation mark, map exclamation mark, because if you say kittens equals cats dot map where type is kitten, right? That means it will create 2 objects in Ruby, kittens, and also it will have cats. But if you just say map exclamation mark, it will just use the first one and just make it smaller, just reassign it. So the less memory you use, the better. And that was a big problem for us, for some parts of our app, that we use a lot of memory for importing data and stuff like that. Okay, now I want to talk about Rails. So in Rails, active record may be slow because Rails gets back data from the database and then it tries to create models, instances out of these database records, and models can be really heavy. I will show you some benchmarks after the slide, just so we can measure how slow it is. So sometimes instead of using cat.all.something or cat.where, it's better to use find by SQL. It's faster to use find by SQL. Find by SQL, yeah. Also the views are really slow. So all views in Rails are really slow, but we have a one-page app, and we used to use JBuilder, and JBuilder views are slow. So now we use JSON serializer for most of our actions because it's the fastest way. Basically, JSON may be 100 milliseconds slower than just plain active record serializer. Also, you probably know about data preloading, and also load the models you actually need, and don't load models you don't need. And also, for example, dependent, delete all as opposed to destroy. Do you guys know what it means? You know, can you explain?
Destroy cause the callbacks.
Yeah, destroy will cause
Directly to the database.
the callbacks, and delete all just runs one query, which is good. And it's the same that use in instead of like where, many wheres. And that's how our new relic looks like. Most of the biggest part of this cake is Ruby. So you see, database is like small, like yellow kind of sand. It's like a beach, right? This is sand. On the top is like some green, like woods, like forests, and then the ocean, and then garbage collection execution is a small line, and then request queuing is kind of the other side of the island. And I just wanted to measure, like, to show you how fast it is using active record based connection execute without triggering models. And I just prepared this like small test. So here, as you see, I think I should make it bigger, right? Yeah, sorry. It just got a little slow. Is it good enough? So here we benchmark just plain active record connection execute. That will give you just JSON of customers, just a hash of customers. And here we actually will recreate the models and see which is faster. Okay, now I am in the console, and I have like an example database with a bunch of records. Now I'm going to fetch 100,000 customers and one customer. And actually, I did it again.
What is the corpus of data that we're looking at, Michael?
It's standard benchmark data. I don't remember. We just compare them. So basically, it needs 2 milliseconds or 2 seconds for the whole operation. 2 seconds.
I mean, who are these customers?
Oh, the customers are threads. It's like your friends on Facebook in Facebook messengers. So in our system, customers are like those threads who message with you.
So did you just like pull down a staging database? Or did you generate a bunch of fake data?
This is a generated fake data that I generated.
You use a tool for that, or just register it?
No, we just wrote a script that generates it in database. And here, as you see, it's 2 seconds total. And now I'm going to use the models. The database actually ran faster, well, about the same, but we see that the time consumed is like at least twice bigger for the same operation. It's actually just count. Yeah. So without triggering all this generating of models, instances, it gets a little bit faster. And sometimes when you have an action with like super high through output, you can actually save. You can save the customer's tiers just using directly database. All right. The next thing, if you have a controller that is being slow or sometimes gives you timeouts, you can always change it to a worker and then update your front end with either polling or WebSockets. For example, if you have a data export that will take like 15 seconds to run or 20 seconds to run, you don't want it to just use it with like normal controller action triggering. You want it just to execute the worker, and when the worker is done, it comes back to a WebSocket or a polling and say, okay, data was imported, or image processing, or using third-party APIs, waiting on some kind of Google API until they respond. Also, workers help you to distribute all loads of work in time, because sometimes you may be busy, especially in messaging. Sometimes we are super busy, but sometimes we're just not busy, just nobody sends messages. It's like everybody is like having lunchtime, or everybody is watching everybody Star Wars, right? So it's very helpful to distribute work in the time. Have you ever used queues like Sidekick?
What was the question?
Have you ever used any queues like Sidekick? So only 1, 2, 3, 4, 5. I see. So that was a good example of asynchronous work. Yeah. So that's why using queues is very important. For now, we use Sidekick, and we have 5,000 RPMs in our hard time, when we have a hard time. And we'll see if you can just survive with one Sidekick. Sidekick is a little bit hard on Redis, because if you have like a bunch of tasks, sometimes in Sidekick we have like 200,000 jobs, right? And it may be a little bit harder for Redis when you have a bunch of workers that execute those jobs, like let's say 50 workers that execute those jobs, and they're really fast. It may just use so many Redis connections because it's just so spammy to Redis. And we know if we have like a hard time, we usually increase our Redis just because we want to increase the connections, so Sidekick can work better. Well, the next part is tests and reports. We basically want to test as much as possible, because sometimes we had things that we didn't test, and it was really painful. You guys probably know. Hopefully, you guys know how bad it is sometimes not to write not to write a lot of tests. And we have integration test, acceptance test, and some benchmark tests. 2 benchmark tests. We also use Circle CI, which is great. So our tests run 7 minutes. It's a bunch of tests. It's a lot of tests, and they run 7 minutes on CI and like 20 minutes on my machine. The slowest tests are acceptance tests, because they use front end. We also do some things with third-party APIs. They are slow. But on Circle CI, you can just run tests asynchronously. Just push. You guys know what Circle CI is, right? No. Basically, it's Circle CI is a project. It's a startup that you can just push a new version to GitHub, a commit to GitHub, and it will run tests for you in the cloud. So you can run a test in the cloud, and it's really useful too. We love it so much, because we can see like it will report to us, hey, you just pushed this branch and test didn't pass, ha 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 ha, and you're like, shit. So it's also good for visibility. You make a pull request and you see if test passed or not. So you can merge it based on like if test passed or not. And Circle CI, you also can like improve the configuration. You can have multiple boxes, so it's so much faster than my MacBook Air. Talking about Air, we use Airbrake, and we immediately have to know if something happened, so we can fix it as fast as possible. We use Slack integrations for Airbrake, and it works. It just works so well. As well, yeah. And we have some extras for you. Some extras. We use Elasticsearch too, and it worked really well. It made it so much faster to search. We used to have like SQL like for a little bit, and our search functionality was limited to just names, phone numbers, and a couple more key data. But with Elasticsearch, we search through everything, and it's just super fast.
Sorry, what's Elasticsearch?
Elasticsearch is a way of let's say it's like a separate app or like a way how you organize your search. Basically, it caches. It uses like smart caching to like organize your search algorithms, so they're cheap and fast. Basically, it's kind of cache.
It's a search engine.
Yeah. Yes.
It's a search
Thank
engine
you.
built on top of the scene from Apache.
And
Optimized search logic and optimized memory usage.
thank you. Yeah, basically you can define how you want to search things.
It builds an index like Google index, and
Yeah.
then it goes and reads that index, and it basically creates your content, and it puts it into tables, and it can search through these tables super fast.
Also, a couple more gotchas with regard. Instead of REST client and all the standard HTTP requests, if you use, I'm not sure how to pronounce it, typos is like much. It basically uses curl. It's so much faster. And then, for example, high Redis is a Redis library, but built in C++. And I have a friend saying that he rewrote some things in C++. You can do it with basically Rails, and you could have some, like, let's say, slow calculations that you do, like have a bunch of slow calculations. It's faster to make them in C++ and like make a gem, build it, and make a gem.
Can I ask a question about
Yeah.
Elasticsearch?
Yeah.
So, what do you? So you're indexing the text of every message. Like what's the use case?
Yeah. So we index text on every message. We index full name. We index first and last names. We index phone numbers. We index properties on the customer in a specific way. So you can search pretty much through like a lot of things.
Was there any particular reason you used Elasticsearch rather than Postgres's full text search?
Yeah. It was super easy to connect, and Postgres was like slow, even for names it was slow. If you just use names, in our list of like slowest actions, search was like the slowest. It's like super slow.
And when do you do your indexing to Elasticsearch? It seems like that could be kind of slow if you're doing that.
So we index if data changed, it triggers Elasticsearch API with like data update. Well, it's lagging maybe a little bit, like a couple seconds or 1 second, but Elasticsearch works really well.
Do you have a plan for like? It seems like you don't need to be able to search every message ever, because that would be kind of expensive to keep a Elasticsearch cluster with so much memory. So you have a plan for. It sounds like you are doing that now. Do you have a plan for how? When you have 10 times the number of messages, you're going to. Well,
I think it does it. It does it in a smart way. We haven't thought about it yet because it's pretty cheap for us to like, even if we have tens millions of messages. It's pretty cheap. It's all we pay for Elasticsearch is $100 a month, and with millions of customers, millions of messages, it works great, and like it's just super fast. And Stack Overflow was great. And I don't have a final slide. But that is the last slide. Yeah, I'll update my presentation with the final epic cat slide, but I don't have it now. So if you guys have any questions, now it's time to ask.
So you're still on Heroku?
We're still on Heroku. It's very nice to be able to easily change the amount of dynas depending on like if you have a hard time or like not very hard time. it's easy to change like more or less dynos.
You're not using any scripts to automate it to say, hey, when the throughput goes.
No, we don't. So we don't. We are thinking in this direction. So we have a couple of thoughts, but we never implemented yet. Probably we should implement it soon. But we were debating to go to Amazon because for multiple reasons. And we are thinking either we implement this automatic strategy for Heroku. Sometimes we need more workers, sometimes less workers, depending on like if a lot of people use us. It's actually pretty good. It's the next thing that we're gonna do. Automate that process.
Now that you've like seen what Rails is capable of, are you thinking about sticking with Rails, or are you thinking about maybe switching to something that is uses less memory?
Yeah, for example, so for now we don't have any troubles, any big troubles. I think we can go like pretty far with it. But maybe, so we use Node.js too recently for some integration. We have another Node.js app, and we communicate with Rails app through Redis. Redis has subscribe functionality. It also, you can create lists, like create small queues, lists, and then pull and push to the lists, so you don't lose any data if there are connectivity issues. And what I noticed about really simple Node.js app, it's so fast. It's so fast that it just, I'm just enjoying like using this Node.js app all the time because it's just instant. It's like crazy. So I'm thinking for some API calls to our server, like for example, when the user is typing and not typing, like this kind of calls that just has something to update Redis, use maybe Node.js, not Rails, because Rails is heavy to accept those queries, and Node.js is really fast. But yeah, for some easy API calls, internal API calls that we use, maybe using Node.js. I think it will improve functionality. Yeah, and in general, all because we have a one-page app is React, so all our front end is cached. It's really fast, and then API is the slowest part, which is also fast, and everything is possible also cached. But still now the Ruby is slow, even though everything is cached, because you go to the controller, it's pretty deep. Rails pretty deep. Ruby is kind of maybe a bottleneck for some things, and maybe I haven't tried it yet. But if you use Node.js more for like some easy API calls, like for that you can like module out like as a service, that'd be a good experiment to do, and that will increase our productivity.
How about the WebSockets? It seems like that's something that Ruby really sucks at because it takes so much memory to keep the connection open. So you said you are using WebSockets?
We use WebSockets, but we use PubNub.
Okay. So vendor to keep it.
Yeah, and at one point we're gonna stop using PubNub. So we use all latest versions of Ruby, Rails, not the 5, but I'm really curious if we could migrate to 5 that easy. And I'm really curious to see how WebSockets on the 5 work, and if they work really well, and that'd be really good. And
complaints about PubNub, otherwise it sounds like, is it just because Rails 5 does WebSockets?
Yeah, complaints about PubNub is very expensive.
Okay.
It's expensive, and we used to have some troubles with it. They fixed it, but there was a bug that they didn't fix for some time for us with a blocking call. But I went to their office, and they basically documented it, and in a couple of months they fixed it. But before they fixed it, we monkey patched it, and we used monkey patched PubNub for a little bit because it's kind of legacy. Maybe if
there's a bug in their like.
Yeah, in their library, in their JavaScript library. I would probably use the other one.
Firebase?
Not that one. The other service. Not parse. Pusher. Yeah, I would use Pusher if I would choose it. But still, we're gonna definitely do our own WebSockets very soon.
Why didn't you write it yourself? Why did you choose to use like PubNub to do it?
Because it was already there, and the second reason is because we are limited on dev power. Dev power is one of the bottlenecks. There's so many features to do, like billions of features. It's like a queue, sidekick queue, right? There's only like couple, 3 workers, and there's like a bunch of jobs. And basically, you want to accomplish as much as possible. So we stayed with PubNub to simplify, so we can like accomplish like more important features. Yeah, and of course we are hiring, and that's how everybody introduces themselves in San Francisco, any startup. Hey, we are hiring. My name is Michael. Hi, we are hiring too. My name is Josh. Yeah, we need, yeah. We are hiring, and there is a lot of benefits working for Sonar. You get a free account. You'll be able to message whoever you want to. Well, that's a perk. Yeah, we have health insurance. Any other questions? Any questions that you're just shy to ask? Who don't have any questions?
Oh, did you post these somewhere?
You know what? I'll post this presentation to the whiteboard. Yeah, after this class. And maybe I'll tweak it a little bit and then post it. But tonight. Yeah, if you have a feedback, what was useful for you and what was not useful for you, can you just guys give me a feedback? Was it like anything that was a little bit useful?
I just
Yeah.
think it's really cool to have a story, like these stories, you know. Because we all scale things that are less interesting.
So you wanted me to add more like story element?
No,
So
I think it's really cool.
It is already cool.
oh, okay. Thank you. Very nice.
We're really grateful that you.
But it's a good idea. I should add a story. And then I came there. I opened the code and I started crying. Something like emotional, right? That'd be awesome, because you know all these presentations are the same. Like, hey, cash. Everybody says cash, right?
I think some examples would be some more like in-depth examples.
Oh, okay. More concrete examples.
Yeah, like the cash thing, like I kind of already know, but I would love to see what you're doing as well.
Okay.
Just
Yeah, as I was saying, like,
some more solid
what
examples.
level of caching did you do? Like, I don't know, fragment caching your page or
Model.
Yeah. So we do all caching, like every caching. Basically, because we have a one-page app, we don't really need to do like page caching, right? Because everything is already cached. We have like JavaScript and HTML that we just launch each time you go to the website, and then that JavaScript will launch API and go and grab some data, right? And some of the requests we just cache completely, just as a request, and some of the requests we cache some information and don't cache. We cache it with validation. So we cache validation, right? If a user is valid or not, because you know to figure out each request goes to the server to figure out like if the user has a paid account that is valid that does support this feature. It's like it can be like a lot of work if you have like a lot of requests to the server. So we cache all this validation, and you just go to Redis and ask, hey, is this user valid? And Redis will say yes. And then if your payment method changed or something, it will change the cache of that object. Basically, our concept about cache is something temporary, something expirable, and if you delete all cache from the server, the app will work. We'll just recache everything again. So I can just go to our app and just delete all cache, and it will be a little slow in the beginning because it will have to recache everything, but it will work well. Yeah, nice. So some concrete examples.
I think some more feedback, like a little bit more explanation of like what is RDS and like what is, you know, like what is garbage collection. Maybe depends on the audience, but
I think at the beginning you should show a diagram of your app so we can see
Oh.
what's plugged into where, and then that'll sort of help our brains process the rest of the puzzle.
Oh yeah, I see. Yeah, basically garbage collection. There's a lot of developers who write garbage code. A magic thing called garbage collection to go and just take all the garbage and put it in trash bin.
And when you said you were logging into the database and that was a disaster, where did you end up logging?
Oh yeah, that's actually a good question. We are gonna use we probably 99% are gonna use a product called CloudWatch. It's on Amazon that is really useful for something like logging. Gabe recommended that product actually. But now we use Redis to we use logs, but it's just all logs, right? But we use Redis to cache the counters, like amount of different requests of different types, and we use cache to Redis to cache the last API calls. I think it's 50 API calls. They just you can see the hottest calls, and then if it's not sufficient, we can go to the logs and like find some data that you need. Yeah, we used to use the database for logging API calls in the beginning. It was fast for the beginning, but then because we have a lot of API calls, there's customers who like send like bazillions of messages to API, and just the API table got so huge. So and it has indexes, and we just removed the whole table.
Earlier you promised that you would explain to us how to calculate how many dynos we need based on our request per minute.
Oh yeah. So there are on the web there are different ways of calculations, right? There are formulas that based on average response time and request per minute will show you how to calculate how many dynos you need. But also now Heroku actually introduces several types of dynos. And I calculate it just like that. So I go to New Relic. New Relic and see the average time, right? 80 milliseconds. And if it's about 80 milliseconds, we don't need another dyno. But if it gets slower and everything normal, there's no like a bug or something, then we need an extra dyno. In Heroku, they have like several types of dynos. They have like normal dyno, and they have double dyno, and they have super machine dyno. So basically, you can just calculate dynos that easy. So basically, you just can see how slow your app is based on like average response time in New Relic, and calculate and see if you need another way of dyno. But for workers, is simpler, but there is a bottleneck with Redis that I told you. If you have too many workers, you have to increase Redis because they are really noisy for Redis. If you have more jobs, if your jobs increase and not like decrease, then you probably need more workers for sidekick jobs.
What vendors are you using for Redis and search?
Search?
Yeah, for those two components, where are you hosting it?
For Redis, we use Heroku Redis. And for Elasticsearch, we use a service made by Elasticsearch. Elasticsearch, yeah. It's so much cheaper than Heroku. Elasticsearch, Elasticsearch, Bonsai is like super expensive and inconvenient. This is Elasticsearch is something that made by Elasticsearch. It's like their paid product, and they provide you API, and it's very easy to integrate, and it was really cheap. I mean, not really cheap, but much cheaper. And also OpenTable, Wikipedia use. Yeah, we just decided to use this one because it was much cheaper, and it was like out of the box solution. So we didn't have to spend much dev time on it. Launching Elasticsearch on our server, especially with Heroku, is kind of with Heroku is impossible. They want you to pay for Bonsai.
Like I really want to ask to see some code, but that would be fair. But I think with the concrete example that somebody asked for, like it might be pretty easy for you to say, all right, this code's kind of not that exciting. I can show some of that.
Well, but it will go to feedback.
I like the screenshots of New Relic. I think they describe the situation well.
So, screen relic. Okay, you can.
Actually, I'm sorry. He was first.
Hey, I'm sorry. You can.
So I have 2 questions.
Yeah.
What is a loop state worker? What is the worker? And 2, I understand kind of basic what caching is.
So worker may be confusing. Usually, worker is something that is async. That is while you are browsing the web, is some other thread that is on the server, like doing some other job, right? For example, while you like browsing the website, there are 3 workers sending messages that you already sent, but because too many people send messages at the same time, they were queued. So they take a task out of the queue, complete it, and they take the next task. But also there are Puma workers. That's a little bit confusing. So usually workers is something async, but there's also Puma workers, which is just a thread of your app. So basically your app is being run on multiple servers, and you have like one thread, one instance of your app run into a Puma worker. So it's a little bit different. But just remember workers as a sync thing.
And caching.
Caching is something that you temporarily keep in a very fast storage. Thank you. You had a question.
I had a comment about. I was just saying.
Oh yeah.
I like your presentation. You know, the slideshow works great.
Slideshow. You said Kittles, right?
I understand that like not everybody can, and it seems like you've done this one before, so you may have had it already in your pocket. But what's that?
It was the first time.
First time? Okay, cool. Well, I mean, I just love that
Well,
you laid out very well. You took the time to to do it. I understand not everybody can, but that was awesome.
I like your indirect way of saying that you like cat pics.
Dog person, but I just love that.
A dog person, yeah. More dogs. Equity.
I would just use my dog over and over.
People actually find that kind of like arrogant. I'm trying to.
Oh, I have a question.
Yeah.
About WebSockets. Like, did you have any issue, number 1, on Heroku? Because I know there's like an issue with like long polling. Like, you can't really do long polling on Heroku. And second is like, did you have any issues with scaling to multiple workers?
Multiple workers of which
so
workers?
like, if your app has multiple workers, did you have any issues with WebSockets? Like in terms of like sending the heartbeat and doing the handshake?
We never had that issue with multiple workers. You use Firebase?
I wrote my own WebSocket.
Okay.
And it's, I'm trying to fix that problem.
Yeah, that's interesting. I imagine that they need some kind of unique key for the instance or something like that. We never had these issues with PubNub. It worked really well.
Okay.
And long polling, I think it worked for us.
Because you know how there's a timeout, like.
Yeah, 15 seconds by default. You can change it, but it's 15 seconds.
Okay.
But so your long polling should not be longer than 15 seconds. That's it, right? Or you can change your configuration of Heroku to have request timeout longer than 15 seconds. The maximum is 60 seconds, but nobody will recommend you to do that. So you can do polling like of 14 seconds. and that probably work. Check request timeout Heroku. Any more questions? Feedback? Do you have feedback?
Maybe, well, I was thinking maybe like a list of like the whole stack and split that, what third-party products you guys are using, and like description.
Or just give me access to your GitHub code. Maybe. Full stack, yeah, it's interesting. More explanation about stack.
Something pretty easy that I think would be really awesome is just a list of links to the vendors and libraries, open source libraries you're using, because you know what those things are, and it would be it'd save everybody a lot of time when you Google them.
Nice. That's a good.
Show your jump file.
Huh?
Show your jump file.
Yeah. No, I keep my links to some videos, secret videos. I can show you.
Well, I have a question.
Yeah.
I'm actually working on this new project at work.
Yeah.
Basically, I've been using Rails footnotes. I don't know if you're Rails footnotes, Jen.
What gem? Which gem?
Footnotes.
Footnotes?
Yeah.
I never heard of it.
It's pretty good. It tells you what variables are being used, like what considerable rules, and what JavaScript are being rendered, and
Oh.
what queries are being used. I have an example. I could screen share. You guys could take a look at it.
That sounds so. It basically gives you information about the stack.
Yeah, right. I can show you.
If you can just so if you come right here to the Rails class, it's supposed to show you a link, right?
It's just light colored.
Can I share my screen?
Yeah, and you'll be able to share your screen. Did you find this link?
It's the join hangout blue button.
Oh yeah, see the join hangout?
Let me go through.
Yeah, that sounds fun. So it gives you. I usually use gem file lock for this kind of thing, but it's inconvenient. It's just you have to look for a gem.
Just join the.
Yeah, just click join hangout, and then I will see you here in this interesting screen. Have you joined?
Yeah, I just joined anything second a while, I think.
I think Google will run out of memory.
It's screensaver.
Yeah, it's like a screensaver. A flying mice.
So trying to join.
Oh, really?
Yeah, it's just thinking.
Yeah, it's okay.
Does OS X have like a kitten cursor? Kitten for your mouse?
They didn't tell it out. Poor user experience.
Then kittens floating in space.
Yeah, cool. Yeah, while we're waiting, do you guys have anything else? Any other feedback? Or this is over? No more feedback. Well, awesome. Huh?
I'm curious if anybody's new to Rails School. One person. Michael, would you maybe tell us what this is about? Our organization.
So a Rails School is some kind of a class or meetup where people teach on their things they want to teach. So we have a class once a week for the last 4 years. Yeah, and it's free, and it's always free. And thank you to this Hackerspace for providing us the space. Where are you guys from? From San Francisco?
Yeah.
Awesome. You're probably developers, right?
Yes.
Okay.
Right.
No, I could just tell seeing your face being a little bit bored, another presentation about scaling. Did it work?
Just let me try again. I felt like stuck.
Yeah, I think they're caching something wrong in Google. Thank you for coming.
Thank you.
Yeah, just send it. Yeah, just send it.
Oh, you know what? You can just come here and connect your laptop.
Yeah, I think that's probably better.
Fun.
Thank you.
Yeah, thank you for coming. Thank you for questions and helping me out with Elasticsearch explanation.